Hey guys, welcome back. This is your math teacher, Ayon James. In our previous lessons, we learned about vectors, what vectors are. We found out that we learned about operations of vectors. We found that vectors can be added. So if I have two vectors A and B, I can add these two vectors together. Then we also found out that we can subtract one vector from another. So I can have A minus B. Then I told you that we can multiply a vector by a scalar. Okay, so it means that if I have vector A, I can multiply vector A by a scalar k, where k is a scalar. Of course, we know that scalar quantities have magnitude, they do not have direction. So we can have multiply vectors by a scalar. Today we'll be looking at what happens when we multiply two vectors together. Alright, and for that, we're going to say that we have two ways in which you can multiply two vectors together. We have what we call the dot product, which is what we'll be talking about today. We have the dot product and we have the cross product. Now, the dot product is also called the scalar multiplication of vectors, and this is because when we multiply, find the dot product of two vectors, our result gives us what? A scalar quantity. Okay, so the dot product of two vectors returns a scalar. Okay, we also have what we call the cross product. Now, the cross product is also called the vector product. Okay, so the result of the cross product returns another vector. Right now, um, if I have two vectors, if I have vectors A and I have vectors B, now if the angle between them is theta, the dot product of these two vectors gives me A dot B is equals to the magnitude of A multiplied by the magnitude of B, then the cosine of the angle between it. Okay, so the length of A multiplied by the length of B multiplied by the cosine of the angle between this, which is cos theta, between these two vectors. Okay, now what we need to know about dot product is that when you're asked to find the dot product of two vectors given its component, all you have to do is to multiply the components together. Okay, so here's what I mean. Here's what I mean. So if I have the dot product of, if I have vector A, if A is resolved into its components as A1, I have vector A with components A1, A2, and I have vector B, the components B1, B2. Now the dot product of vectors A and B will give us A1, B1 plus A2, B2. So all we just have to do is to multiply their components together. Okay, so let's look at a practical example. Let's say we have okay, let me clean this. let's say we have vector A as let's call this, let's resolve into its component as 3i, where I is a unit vector, plus 4j and let's say vector B is let's call this I plus j. Okay, so we have let's call this I, say I plus 3j. Alright, now if we want to find the dot product of this, all we have to do is to multiply the components together. So we'll have that A dot B gives us, alright, now the component of A in the x direction will have 3 times 1 plus 4 times 3. Okay, so this gives me 3 times 1 gives me 3 plus 4 times 3 gives me 12. Now 3 plus 12 gives us what? 15. Now just as I explained, we can see that the dot product gives us a scalar. Okay, so when multiplying these two vectors A and B together, you can see that when finding the dot product of these two vectors A and B, you can see that our result gave us what? A scalar quantity. Okay, now your dot product should not be confused as the scalar multiplication of vectors. Now, when we multiply a vector by scalar, just as I told you, the result gives us another vector, okay, having a different magnitude but in the same direction. Okay, so let's say let's still use vector A as 3i plus 4j. If I say you should find the value of 4a rather, now 4 is a scalar. I'm multiplying 4 by multiplying the vector A by this scalar 4. All we have to do is to just multiply the individual components here. So this will give me 4 times 3, which gives us 12i plus 4 times 4, which gives me what? 16j. Now I want to note that the vector, this new vector 12i plus 16j is in the same direction as 3i plus 4j, but the magnitude is 4 times that of what? A. Okay, now then their vectors have some, dot product of vectors have some properties. The dot product is commutative, so it means that a dot b is equals to b dot a. It's also distributive, so it means that a dot b plus c is equals to a dot b plus b dot c. Right? Now I'm trying to keep this video under 10 minutes. Okay. Now in the next video I'll explain more about vector dot product of vectors and how we can find the angles between two vectors. But right now I believe we know how to find the dot product. Okay. And we know the difference between the multiplying a vector by a scalar and the dot product. Alright, so if you have any questions, please you can reach me on my Telegram page. Alright.